Good day. I would like to introduce you to the members of the team. We'll start with Megan, who is our theoretical engineer, Brian, who is our scientific historian, and I am Bruce, the storyteller. You may remember the Beagle 2 mission to Mars failed and crashed into the Red Planet. There has been talk the debacle resulted from the lack of substantiation between the French and the Americans, particularly their scientific calculations. It seems, when calculations were passed to the other team, the units were omitted as not being important. So the French were using meters kilogram, while the Americans used feet and pounds. Because of this, a simplified portion of the guidance system has been forwarded to this team for analysis before further investigation into the situation. To facilitate the simplification, we'll use the theorems from Leon Thevenin, the French engineer, and Edward Norton from US Bell Labs. We received the original circuit. As you can see, this one has a voltage source on the right and a current source on the left. To simplify this circuit, we'll use Norton and Thevenin theorems. When we're done with our simplification, we'll have one electrical source and one resistor. The derived circuit will be electrically the same to any load placed upon the terminals as the complex circuit. The purpose of all this is to make analysis of loads easier, which translates to simpler. Now we'll work with a picture. This circuit that you see is the original circuit, and the 3K resistor in the middle is the load resistor. The second circuit shows the original circuit with the load resistor removed. All calculations will be made relative to where the load resistor was and on designated terminals A and B. We will now simplify by combining the resistors. On the left, we'll take the two resistors, the 1K and 2K, in series and substitute it for a single resistor 3K equivalent. On the right, we have two 4K resistors in series, so we will substitute them with a single 8K resistor. Now, we'll separate this circuit at A and B and make two circuits. We chose to work with current sources as this was easier. The right half is a voltage source and already configured as a Thevenin circuit. So we will convert it into the Norton equivalent. The left half already has a current source. On the left half, since the resistor is in series, it has no effect because the current will always be 1 milliamp. So we choose to remove it. Now we have the two circuits, current sources, and resistance simplified. We will now combine the two circuits, and I'm sorry, I've lost my calculations. Now you know why we work as a team. We'll combine the two circuits now. You can see right here we have current going down at 1 milliamp, and over here we have current going up at half a milliamp. Add the two together, we have the equivalent of half a milliamp coming down. So the two current sources have been combined. We take the resistor and put it in parallel the same. And that makes our Norton equivalent, current going down in parallel with the 8K resistor. The Thevenin equivalent is a simplified matter to find the voltage by multiplying the current through the resistance, and the voltage becomes 4 volts, half mil through 8K. We have to watch out for the polarity because the current is going down on the voltage source. We also want the current going down, which means the plus lead going down. And we have the 8K resistor in series. Now we can use either the Norton equivalent or the Thevenin equivalent circuit and place any load across the terminals A and B, and it will behave exactly the same as if we had the original circuit. Our comments on using the MyDAC for this project. We had only one problem using MyDAC to breadboard this circuit. We needed two independent sources to replicate the two sources given in the original circuit. Generating the 4 volts with MyDAC was no problem, but the student edition of MyDAC is not equipped to generate 1 milliamp source. Voltages, yes. Current, no. So I was going to generate a second voltage with the same characteristics of the 1 milliamp source. Unfortunately, that did not work. For this circuit to work, we needed 2 independent sources. And the MyDAC sources are not independent. They share a common ground. Every time we connected the voltages up to opposite polarities, it would short out. Hence the need to use a battery and a variable resistor for the second source. Once that problem was solved, everything else went as planned. In the accompanying Word document, we have the pictures, the hand calculations to verify what we have presented here today. This concludes our presentation for the day. Oh, before you leave, on a side note, if any of you have a desire to visit the Martian colonies, for additional fee, Brian will be glad to document your experiences there for posterity. Please don't rely on my photographic skills for your memories there. Instead, bring your own camera. And I'm sure your trip there will be pleasant and successful because Megan has done her work well. But be careful. The return trip was planned by the French, with whom we don't talk to very much.